Now we're going to talk about domain and range of continuous graphs. So continuous is different than discrete. Both are graphs, right? Discrete is just a set of individual points, and we listed the domain, least to greatest, numbers don't repeat. Domain and range of continuous graphs, you've got millions and millions of points, infinitely amount of points that we could never list from least to greatest, numbers not repeating. It's not possible. So there has to be a different way to name domain and range of continuous graphs, and there is. So first, how do you find domain? Remember, domain is all those x values, right? So all you have to do is you scan your pencil all the way left and see how far to the left that graph goes, and then all the way to the right and see how far right that goes. So we're just going to scan pencil from left to right and identify the x values that would essentially touch this graph, right? So if I extended this graph all the way left and all the way right, what would touch the graph? For range, it's scanning the pencil all the way down and all the way up. So you scan your pencil down and up. Remember, in math, we always go from least to greatest. It's the same thing with the continuous graph, least to greatest. We have already done domain. We did it last unit. Remember when we had those compound inequalities? So I'm just going to go over here and kind of remind you of what we had. And we had a graph, and it looked like this. It would be -3 and 5, closed circle all the way left. And we said it went negative infinity, and it came to -3, and we put a bracket around it. And then we said or, and then it started again at 5 and went to infinity. Remember when we did that? That's the same thing. That's all we're doing. And we're going to use inequality notation. We used set and inequality notation before, and now we're just going to use inequality notation. So if you look at number 1, and here's my graph, and I went all the way to the left. How far left is this graph going to go? It's going to go all the way to negative infinity. And how far right would it go? It would go all the way to positive infinity. So if my domain is negative infinity is less than x, which is less than infinity, right? It's all real numbers. So you can write it this way. That's my inequality notation. If I use interval notation, it would go from negative infinity to positive infinity. But I can also say it's just all real numbers. It means it's going to be every single number that we have, right? All the way from negative infinity to positive. And for me to use all real numbers, it's 2 parallel lines and then the letter R. That stands for all real numbers. Okay, so that's my domain. Now, let's talk about range. Range is, we haven't done range, but it's the same thing. It's always least to greatest. So remember, negative goes down here, positive goes up here. So how far down does this graph go? It goes all the way to here. It is never going to go below -2. It's just not going to go below -2. It's not going to do it. There's nothing else down here. So my range is going to be, the lowest point is -2, is less than y. Remember, range is y. And then how far up is this going to go? Look at my arrows. It's going to go up and up and up and up and up forever and ever and ever. So it's going to go to -2 is less than y, which is less than infinity. Least to greatest, right? You can also say that y is going to be greater than or equal to 2. And this should be, it does equal to, because it's not, it would be an open circle if it didn't touch -2, but it's touching -2, so it's -2 is less than or equal to y. So for your, you can do this one of 2 ways. You can say y is going to be greater than or equal to -2, or you can keep with that and statement, -2 to infinity, okay? Let's look at number 2. So number 2, how far left does this graph go? Well, look, it's got a stopping point at -3. How far right does this graph go? It goes to +3. So remember that and notation. My domain is -3 is less than or equal to x, which is less than or equal to 3. Because x includes all those numbers in between, right? So least to greatest, my arrows always go the same direction when I'm least to greatest. and it's going to be less than or equal to. All right, let's look at our range. How far down does it go? It goes to -3, and it goes up to +3. So my range is going to be -3 is less than or equal to y, which is less than or equal to +3. Okay? Now, really take a minute to look to see if you understand it. We're going to be doing all of these together because sometimes this can be tricky, but I think you guys will get it. All right, look at number 3. How far left does this graph go? It's going to go left forever and ever and ever, all the way to -infinity. And how far right is it going to go? It's going to go all the way, all the way, all the way to +infinity. So my domain is going to be all real numbers, okay? Because it goes from -infinity to +infinity. You can also say -infinity is less than x, which is less than +infinity. Any of those representations would be fine. Now, let's look how far down this graph goes. Don't get stuck on just this y-axis. Look how far down. If this graph were to continue, it would go down forever and ever and ever and ever and ever. Never and ever. And then it's going to go how far up? It's going to go up forever. So it's going to go down and up forever, which means my range is all real numbers. Okay? All right, let's look at my domain here for number 4. Remember, how far left and how far right. So if this arrow tells me this graph's in behavior, it's still going to go down and to the left forever and ever and ever. So if you went, it's never going to stop going to the left. It's going to go down and out forever, and it's going to go down and out forever. So my domain is going to be all real numbers. Let's look at my range. How far down is this graph going to go? It's going to go down forever. It's got arrows. It's going to go -infinity is less than y. That's my range. So it's going to go down forever. And then how far up is it going to go? Look. It's going to go right there. It's never going to go above that. So it's going to go to 1, 2, 3, 4, 5, less than or equal to 5. So you can write it like this, or you can just say y is less than or equal to 5. Either one of those is going to be okay. All right, let's look at number 5. How far left does this graph go? It goes here. How far right? It goes all the way here. So it's going to go to -1 is less than or equal to x, which is less than or equal to 1, 2, 3, 4, 5. That's my domain. How far left and how far right. Now, let's look at range. Range means how far down is it going to go? It's going to go all the way down here, and it's going to go all the way up here. Those are my boundaries. So it's going to go -3 is less than or equal to y, which is less than or equal to +3. How far down and how far up. Okay? Let's look at this one on number 6. How far left and how far right. How far left? It's going to go down and to the left forever. And it's going to go up and to the right forever. It's going to extend outward forever in both directions. So my domain is all real numbers. Now, students sometimes get tricked up when they see these certain maximum and minimum values right inside that picture. Okay, it looks like a maximum and it looks like a minimum value. But range is how far down and how far up it goes. Yeah, it goes to 1, but it also goes above 1. It's going to go up forever and ever and ever, and it's going to go down forever and ever. So how far down? Forever. How far up? Forever. So my range is all real numbers. Don't get tricked up just because you see a maximum and a minimum point on your graph. It still goes down forever, and it still goes up forever. All right, let's take a look at, flip over your page. We're going to do that next page together. All right, so these arrows, look at number 7. These arrows just outside represent what this graph would do with the same pattern, okay? So how far left is this graph going to go? It's going to go and extend left forever and ever, and it's going to go right forever and ever and ever. So how far left and how far right? All real numbers. Look at my range. My range goes down here, and it goes up to here, okay? So how far down does it go? It goes to -3 is less than or equal to y. Remember, my range is y, which is less than or equal to 2. So those are my boundaries between -3 and +2, least to greatest. Let's look at number 8. How far left does this graph go? It goes right here to -1. And then how far right does it go? Well, it's going to go in the right direction, infinity. So -1 is less than or equal to x, which is less than infinity. Or you can just use the symmetric property to get x by itself, and you can say x is greater than or equal to -1. Any of those would be fine. They mean the same thing. Look at my range. How far down is this graph going to go? If this graph were to continue, it's going to go down forever and ever and ever. And how far up is it going to go? It's going to go up forever and ever and ever. So it's going to go down and up forever and ever and ever, which means all real numbers. That's my range. All right, look at number 9. Number 9, how far left and how far right? It doesn't go anywhere except one place. That one place is at +2. So x is going to equal +2. It's not less than or greater than, it is negative. It is +2. So if there's only one number, you got to name that number, and x is 2. Now, let's look at my range. How far down does it go? Forever. How far up does it go? Forever. So -infinity to +infinity is all real numbers. Okay, let's look at number 10. Now we have this guy. Look at my x values. How far left is this graph going to go? It's going to go forever. How far right? Forever. It's going to go left and right forever. So my domain is all real numbers. And my range, it is -4. My range is y. It is -4. There's no greater than or less than -4. It is -4. It doesn't go outside. It is always -4. All of these points represent my y value at -4. So it is -4. Let's look at number 11. Okay, so how far left does it go? Now, this is a clear, distinct closed circle, and this is a clear, distinct open circle. So how far left does it go? It goes to -2 is less than or equal to, because it's closed circle, x. And here, how far right does it go? 1, 2, 3, 4, 5. It goes to 5, but it's open circle, so it's less than 5. If that were a closed circle, it would be equal to 5, but it's open circle, so it's less than 5. So it goes from -2 all the way to +5. -2 all the way to +5. All right. Let's look at my range. Remember, range means how far down. So it does stop here, but it goes down even further. It's going to stop at -2, and it's going to go all the way up to +1. So -2 to +1, and -2 is going to be less than y. It's open circle, so that's why it's less than. So -2 all the way up to +1, and then it's closed circle on +1. Look at number 12. How far left does it go? It goes all the way to -4. How far right does it go? It goes all the way to 5. And they're all closed circles, so it goes -4 is less than or equal to x, which is less than or equal to 5. Those are my boundaries, how far left and how far right. Now, let's look at the range. Range is how far down, it goes to -3, and how far up, it goes to +5. So range is -3 is less than or equal to y, which is less than or equal to 5. You see that? -3 all the way down, and all the way up to 5. So that's what my range is. All right, let's look at 13 and 14. How far left is this graph going to go? It's going to go left forever and ever and ever. And then how far right? It goes to +2. And my range, how far down is it going to go? It's going to go forever and ever and ever. And then how far up does it go? It does not go above that origin at 0. Okay, it does not go above 0. So y is less than or equal to 0. And remember, another way to write this is you can say x is, that's an open circle. X is less than 2. X is less than 2. And then my range, you can just say y is less than 0. You don't have to have the infinities, but if that makes it easier for you, you're more than welcome. All right, let's look at this graph here. So I don't know if you can see that on your paper, but look at this graph. Look at what he's doing. He's trying to trick you. That's what he's doing. But let's Don't be fooled. How far left does it go? It goes all the way to -2, less than or equal to x. And then how far right does it go? There's an arrow, so it means it's going to continue on. It's going to continue on in a positive direction to infinity forever. So you can say that x is greater than or equal to -2, or you can say -2 is less than or equal to x, which is less than infinity. Okay? Now, my range. How far down does this go? He goes down to -4, which is less than or equal to y, and he's going to go up forever. So down to -4, up forever in the positive infinity direction. Okay? So that's domain and range of continuous graphs. Sometimes students struggle, which is totally fine. The only way to get better at this is to practice. Give more graphs. Practice that domain and range. But to do that, you've got to come to tutoring. So come and see me if you need help with this. I got more problems for you.